In the vastness of space, the farthest man-made object out there is NASA's Voyager 1. This spacecraft is currently over 22 billion kilometers away from Earth, which is 156 times the distance between our Earth and Sun. It is so far away that it had crossed over interstellar space sometime in 2012. Voyager 1 has now gone beyond our Sun's heliosphere, a boundary beyond which the Sun's gravitational influence on any object is no more. Despite this, Voyager 1 still maintains active communication with NASA's Deep Space Network. Even today, in its 44-year mission, it has found some remarkable things about our solar system and beyond. So stick around as we explore one of humanity's most successful space exploration missions, NASA's Voyager 1. Main mission parameters. NASA created two Voyager spacecraft in the 1970s, Voyager 1 and 2, originally designed to carry out close imaging of Jupiter and Saturn. Both spacecraft had their missions extended and still function today. The two spacecraft launched in the summer of 1977, taking advantage of a rare planetary alignment of Jupiter, Saturn, Uranus, and Neptune that only happens every 175 years. This allowed the two spacecraft to tour these giants with minimal fuel on board and less travel time. Both Voyagers would swing past each of these planets on its way to the next using gravitational assist. Called flybys, this was the primary way in which Voyager studied its target planets. Voyager 1's first flyby mission was Jupiter. The mission began 7 months into its launch, when the spacecraft was 265 million kilometers away from the planet. It started taking a series of photographs that over the coming year gave astronomers spectacular views of the Jovian planetary system. Voyager 1 was the first to capture a color time-lapse movie showing 10 rotations of Jupiter. This led astronomers discovering that Jupiter's surface is a lot more turbulent than previously understood and primarily made out of hydrogen and helium. It also took photographs of Jupiter's main ring for the first time. Subsequent missions have identified this ring as part of a larger ring system made out of moon dust, extending far beyond the planet's atmosphere. Speaking of moons, Voyager 1 imaged the Jovian moons Amalthea, Io, Europa, Ganymede, and Callisto, capturing stunning details of their terrain for the first time. It also discovered two new moons, Thebe and Metis. Then in early 1979, Voyager 1 performed its closest encounter with Jupiter at a range of 280,000 kilometers. All of its onboard scientific instruments worked, except one. Despite this hitch, the data gathered during this flyby radically changed the planetary atmospheric models used by astronomers then. But out of all the incredible discoveries during its Jovian mission, perhaps the most stunning discovery made by Voyager 1 was the active volcanoes of Jupiter moon Io. The data and pictures showed hundreds of active volcanoes on Io's surface. Astronomers discovered that these volcanoes were powered by the expansion and contraction of its surface, as Io traveled around Jupiter in an elliptical orbit every 42 hours. This constant push and pull generated enough heat to make Io the most geologically active object in our solar system. This discovery revolutionized the field of planetary science as we know it. It forms the foundation of our current understanding of moons and outer solar system planets. Voyager 1 used Jupiter's gravitational assist to slingshot itself towards Saturn. It entered Saturn's planetary system in late 1980 and almost immediately started sending in data that altered our understanding of the ringed planet. The first discovery that Voyager 1 made about Saturn was that the planet's upper atmospheric composition is about 7% helium, compared with 11% of Jupiter's atmosphere. The rest is almost all hydrogen. Before this, astronomers had expected the atmospheric composition of Saturn to be the same as Jupiter's and the Sun's. However, the lack of helium in its upper atmosphere is due to the heavier helium sinking through the atmosphere of hydrogen over eons and collecting in pools of liquid helium. This makes Saturn a true gas giant. It is the only planet in our solar system less dense than water. This is incredible because Saturn is almost 10 times bigger than the Earth and 100 times heavier. If there were a larger enough pool of water, Saturn would float in it. Voyager 1 also captured Saturn's moons Mimas, Enceladus, Tethys, Dione, and Rhea. On top of that, it discovered 3 new moons, Pandora, Prometheus, and Atlas. Astronomers discovered that these new moons clear a gap through the particles of Saturn's majestic rings and create somewhat of a space highway system for themselves. It also discovered a new ring called the G-ring and revealed the fine structures of Saturn's complex ring system. Voyager 1's instruments also detected massive auroras around the equator and also around the polar latitudes of Saturn, emitting large ultraviolet signatures. These auroras are made up of ionized hydrogen gas as energetic solar winds pass through Saturn's magnetosphere. This discovery of auroras at Saturn's mid-latitudes remains a mystery to modern astronomers even today, as these giant light shows usually occur towards the polar regions of planets throughout our solar system. However, Voyager 1's crowning glory was its flyby of Saturn's largest moon, Titan. Once again, its plethora of instruments, like the interferometer and spectrometer, allowed astronomers to peer through the moon's cloudy atmosphere. They discovered that it is made out of mostly nitrogen and methane, with a surface temperature of -180 degrees Celsius and a pressure of 1.6 atmospheres. This data suggested that Titan might be the first body in the solar system, apart from Earth, where liquid pooled on the surface. However, these were lakes and oceans of ethane instead of water. Titan's atmospheric methane, in the presence of inert nitrogen, chemically reacted with ethane to produce various hydrocarbons and organic compounds, making Titan an extremely likely candidate to host prebiotic life, so much that it remains a high priority target for astrobiology and extraterrestrial life even today. Voyager 1's flight trajectory, which allowed it to study Titan and Saturn's rings so closely, also sent it on a path northward, out of the ecliptic plane in which most of the planets orbit in our solar system. Its primary mission ended in early 1990, when it took a series of final images looking back towards our solar system from a distance of approximately 6 billion kilometers from Earth. Famously known as the Family Portrait, the image featured 6 planets including Venus, Earth, and the 4 gas giants. From that point on, the spacecraft was handed over to the Voyager Interstellar Mission, or VIM team. The VIM was a 30-year mission extension throughout which Voyager 1's high-gain antenna would continuously receive instructions and send vital data on interplanetary and interstellar fields, particles, and waves, or FPW. More than 30 years have passed since, and the mission is still ongoing today. Voyager 1 was instrumental in characterizing the conditions of our outer solar system environment as it ventured farther and farther away from the Sun. In late 2004, the spacecraft crossed the termination shock boundary, a point where solar wind abruptly slows down and heats up as it encounters interstellar wind from beyond the solar system. This crossing began the exploration of the Sun's Heliosphere, which is essentially a big bubble blown by our Sun to protect its interplanetary system from interstellar particles and radiation. Astronomers then set out in search of the Heliopause boundary, the absolute outer limit of our Sun's magnetic field. Voyager 1 passed through this boundary around mid-2012. It was in interstellar space now, traveling over 61,000 kilometers per hour. It was the first time any man-made instrument performed measurements without being affected by solar particles and wind. At the time, Voyager 1 was at a distance of about 18,000 kilometers from the Sun. This crossing gave astronomers their first datasets to understand and analyze interstellar space. For example, the study of particles ejected by other stars, measuring interstellar cosmic rays and magnetic fields as they interact with the Heliosphere, and the composition of the interstellar medium. As Voyager 1's interstellar mission progressed, the VIM team slowly turned off onboard instruments so that the spacecraft could generate adequate electrical power for continued science operations. Currently, it functions as the ultimate ultraviolet observatory that allows astronomers to look at other cosmic objects beyond the distortions of our solar system. Voyager 1 has enough electrical power and thruster fuel left to keep its current suite of science instruments operational until at least 2025, but communications will be maintained until its power source depletes and can no longer supply enough electrical energy for critical systems. Beyond this, Voyager 1 will keep drifting outward into space, possibly endlessly, or until it gets pulled towards another star system or totally disintegrates and falls apart due to some anomaly. Either way, the significance of Voyager 1 on our human civilization will be far-reaching. It is the first spacecraft that put into perspective our place in the vastness of this universe with the famous pale blue dot image. Furthermore, it also carries the only interstellar message from human beings to any future spacefaring civilization that might discover it. The Voyager 1 Golden Record is a vinyl disc containing sounds and images selected to portray the diversity of life and culture on Earth. So, it is indeed fascinating to think that if Voyager 1 outlasts us all, a small part of us will still be floating through the vast emptiness of space for someone to discover. That's all from us in this video, folks. If you enjoyed this deep dive into Voyager 1, do let us know in the comment section below. Also, check out our video on how NASA was finally able to contact Voyager 2 after a whole year of radio silence. The link is in the description below. Till then, goodbye and see you in the next one.